All right, guys, today we're going to take a look at the day 2 notes of this new unit dealing with quadratic functions. Today we're still going to be identifying characteristics of a quadratic function from vertex and standard form, but we're going to add in there our second learning target of graphing quadratic functions in both vertex and standard form, including the axis of symmetry, vertex, y-intercept domain, and range. All of those terms you guys got a little experience in with the day 1 notes. So that's a great building block into what we're going to be working on today, okay? For the warm-up, for the sake of time, because I know yesterday's video, or the day before I should say, was a lot longer than we're used to. So I'm going to do one of these as the warm-up for you, and then I want you guys to pause this video, do it on your own, and then later on in the video, the rest of the answers in the table will show up, so you guys will be able to see and compare your answers to them. But I want you guys to really try it on your own. Pause as soon as we're done with this example and give it a shot. Okay, so let's get into it. Warm up. Graph of y equals x squared is shown at the right. Given the functions below, determine the axis of symmetry and vertex. Use a graphing calculator to check. Okay. So as I mentioned to you guys yesterday, you're going to see this parent graph of y equals x squared a lot as we move forward. This is your standard comparison graph when we're talking about quadratic functions, quadratic equations, okay? So looking at some of these, okay, here is all the characteristics of that parent graph that they've laid out for us, all right? And you can find out all these based on the equation that they give us. Okay, remember some of the structural features. So let's look at this this second example, y equals x minus 2, the binomial of x minus 2 squared, okay? Do we think this one's going to be opening up or down? Remember, that's going to be identified by our a term, okay? In this case, even though we don't see an a term, it's just like when we had our exponential graphs and equations, we could assume there's a 1 there, and there's no negative sign, so we know that that's going to be a positive 1, so we know this is going to be opening up. Okay, what about our axis of symmetry? How can I find the axis of symmetry for this one? Well, remember, this is actually written in vertex form, though it might not seem like it, but this right here is our h, okay, and even though there's no k there, that just means we know it's going to be 0, right? No need to write a 0 if a value is 0, okay? And our axis of symmetry is always going to go through the vertex, all right, the x point of the vertex. So in this case, our hk, h is going to be, remember, the vertex, the x value is going to be the opposite of whatever shows up, so that's going to be a positive 2. And because there's nothing here, we know it's going to be a 0. And our axis of symmetry is always going to go through the x value of the vertex. Write that as an equation, so it's going to be x equals 2. Now, oops, sorry, I want to get rid of the scribbles I put in the column there. Okay. What about the transformations that I've got? Okay, what is this graph doing compared to the parent graph of y equals x squared? Well, if you notice, compared to the vertex, we're going to be moving our x value of the vertex to a positive 2 as opposed to 0. And that's done on the graph is going to be a shift to the right by 2. Okay? Now remember, I just did all of this by comparing the vertex to the vertex of the parent graph, right? And then looking at the characteristics given to us by the equation. If you need to, go back to your day 1 notes. You can look at all the things that, all the features of the equations that are going to tell you the characteristics of your graph, right? So actually, let's just write them down on our side here. Remember, A is going to be our vertical stretch. It is also going to tell us if it reflects, right? if it reflects over the x-axis. Remember, if it does that, that means our a value is negative. Okay? H and K is going to be our vertex, and then the axis of symmetry, that one is going to be given that's going to be the x value of the vertex. Okay, so you guys can put that on the side if you want to. I just wanted to make sure I had it in writing so you guys can refer to that. What I really want you guys to do now is pause this video, give the rest of these a shot. Really want to see these when you're with your submissions filled out, and then if you happen to get one wrong, cross-reference it at the end of this video with the correct ones that I'm going to post for you. It'll be great practice for you guys, okay? So go ahead and pause that and try it for me now. Later on in this video, check back here for the correct answers. But let's move on for now with a little bit about what we're going to be working on today, okay? So writing equations of quadratic functions in vertex form. Now remember, vertex form looks like this. Vertex form is going to look like y equals a x minus h plus k. This binomial will be squared. Okay, there's our vertical stretch. Here's our h and k telling us the vertex. Okay, just so you guys have that for reference. All right, so let's try to write the equation of each parabola in vertex form. Well, if I'm looking at this first one, remember this is all in comparison to that parent graph y equals x squared. I'm going to notice here that my vertex, it doesn't look like there is any side-to-side shift. However, it has gone down, and I'm actually going to do this in a different color to show you. It has gone down 1, 2, 3, 4, 5 spots. Okay? But it doesn't look like there's a vertical stretch difference or anything like that. So let's just try to rewrite that with a vertex of 0, 5, right? Because it sure looks like that point right there. Remember, this is opening up, so it's going to be a minimum value vertex of 0, 5. Well, let's try to incorporate that into this base equation that we've got. Well, my y equals is going to stay the same. I'm going to go back to my black color here. Y equals no vertical stretch, so there's not going to be an a value written, although we can assume it's 1. The x is going to stay the same. My x value here is 0. Okay, so I'm going to leave it as x minus 0. The h is always going to be opposite, but because this is the base way to write it, and 0, the opposite of 0 is 0, I'm going to keep it in that base form. So I'm going to leave it as y equals x minus 0 squared. And you know what? I'm actually going to erase this and rewrite it so I can get a little smaller so that I don't overlap into the second problem here. So it's actually going to look like y equals x minus 0 squared. Okay? And remember, we've got plus k. Oh, this should be a negative 5. I apologize for that. This is plus k. So really, we're just writing down whatever the sign is for that y value of our vertex in the vertex form. In this case, the y value is going to be a negative 5. So I'm just going to write minus 5. There's our equation for that one. Let's try it with our other one. This one looks very similar. Okay, our origin is right here, so we can see that it has actually moved up 1, 2 spots. So our vertex is now going to still be a 0 for the x value, but a positive 2 as the vertex. So let's rewrite that in vertex form. Vertical stretch appears to be the same, so we're going to make it x minus 0. Again, leaving it as a minus because that is the base format of vertex form, and because 0 is pretty interchangeable in terms of opposites, it is interchangeable. I'm going to leave it as a negative or minus 0 squared. And this one's going to be a positive 2, so I'm going to put plus 2 as my k value for the end of that equation. Okay, pretty self-explanatory so far. I hope you guys are following along. Let's try number 3. We're going to have y equals, I'm just going to leave that as my base. That's what they're all going to start out as. This one is a little different considering it is still on that x-axis. However, our shift this time is to the right 2 spots. So our vertex this time is going to be a positive 2 in the x column and a 0 for our y value of the vertex. Okay, how do we identify that and write that in a vertex form equation? Well, let's just continue on with it. We're going to go stay consistent and make that black. X, I want the opposite of this value, so it's going to be minus 2 squared. And I'm going to have a plus 0 here because my y value is 0. Okay, so if you were to just write this as y equals x minus 2 squared, that would be fine. It is implied that there would just be a 0 here as your y value or your k value for the vertex. So you could just have that, but for the sake of this, I'd like to have you guys write that just to get practice writing out the vertex formula. Okay, so let's get into graphing these. The axis of symmetry is going to be x equals h. You may have noticed that because remember, h is always going to be our x value of the vertex, which is the same thing as the equation of the line we've been using for our axis of symmetry, okay? So the vertex is going to be h comma k, touched on that. When graphing, I must include, okay? So what do we need to see? This is what we need to see. We need to see the axis of symmetry. All these notes videos, I'm still not entirely sure how to spell symmetry every time. Gotta reference it. Okay, that's going to be our dashed line. Through vertex. And what else do we need to see from you guys? Well, if we have a dashed line going through the vertex, we should probably include the vertex. And we need to see 2 other points. Okay? So when graphing, this is what we want you guys to have to ensure that you have an accurate graph. You need to have your axis of symmetry, which is going to be a dashed line through the vertex. You're going to need to have your vertex, and then 2 other points included on that graph. Now remember, to find those other points, you can just use different values of x plugged into the equation to find a y value and make that a point. Let's try it out. Okay? Make a table of values for the following quadratic functions and answer the questions that follow. Make sure that you show the symmetry within the table by placing the vertex in the center. Okay? What they mean by that is let's make this center value, or this middle one right here, that's going to be our x and y of the vertex. That's what they mean. Okay? Hopefully you guys are figuring it out, and maybe you already jumped on it. This middle part, if that's going to be the vertex, well, I can already identify what that's going to be right away because this is written out in vertex form. There's my h, there's my k. I know how to write that out. My h is going to be the opposite of that, so it's going to be a negative 4, and that's going to be a negative 2. So there's my vertex, negative 4, negative 2. Okay? Well, I'm just going to go ahead and graph that since we already got it. So let's go over here, and I'm going to plot the point negative 4, comma, negative 2. So 1, 2, 3, 4. 1, 1, 2. Sorry, started at 2. Okay, so vertex is going to be right there, okay? But I need to know where else I can put my points on this one, all right? So how can we figure that out? Well, let's just go down the line of the x-axis, plug those values in for x, see what y is, and we'll have different points, all right? So let's go to the left. Obviously, is going to be, the next number is negative 5. If I put negative 5 in for x, which is right here, then I'm going to get negative 5 plus 4, resulting in a negative 1. Square that. That's going to be a positive 1. Subtract this 2. and I'm going to end up with a value of -1. Okay? Carrying on with that same method, actually, before we move on, I'm going to post that. I'm going to plot that point also. So we're looking for -5, which is right here. Okay? And then -1, that's going to be right there. So we'll plot my point. All right? Well, we need 1 from the right-hand side as well. So let's just do -3. Go to the right one. I have -3 plus 4. That is 1. Square 1 is 1. -2. That's going to be a -1. All right, so let's plot that point. -3, -1, that's going to be right there. Okay, so now what I have here are the 2 other points that I could use. Remember, that's all we asked for, 2 other points besides the vertex. But for the sake of these examples, I'm going to continue on filling out this table so that we can get an even more accurate look of what this graph is going to look like. Okay? So let's just keep going down the line. I got a -2. What is -2 plus 4? That is 2. A +2. Square that to be 4 minus 2. So this is going to be a +2 in that box. As a -6 for x, that's going to be a -2 plus 4. What, did I do that right? Yes, -6 plus 4 is -2 squared. It's going to be +4 minus 2, also going to be 2 right here. Okay, plotting those points, if I had -2 and 2, that's going to be about right there. -6 and a +2 is going to be there. And now I'm going to try my best to connect these dots and make this look like a parabola. That's about the best you're going to get. Remember, we're not done after doing this. We also need to include our axis of symmetry, okay? That's going to be our dashed line that I believe we've made red throughout this. So I'm going to write the equation in red and also then make the dashed line in red. You don't have to, but I think it's a great way to just kind of visualize what it is for you guys. Remember, our axis of symmetry is always going to be written as x equals the x value of the vertex. In this case, that would be -4. I'm going to make that vertical dashed line through that vertex. There it goes. That's exactly what it's going to look like. Domain. We cannot really tell what our restrictions are from side to side. Sure looks like along the x-axis there are none, so we're going to leave that as -infinity to infinity. Our range, however, does have some restrictions. The lowest point it can go, and remember it's a bracket because this number is included in it, is going to be -2, but it can go all the way to +infinity. Transformations, remember this is going to be a transformation compared to the parent graph. That would otherwise be, that should be touching the origin, but that would otherwise be y equals x squared. In this case, it's going to be shifting, right, because our vertex is different than 0, 0. It's going to be a shift left 4 and down 2. And with that, we have graphed our vertex form equation for a quadratic function. All right. I'm not going to do 2b. I want you guys to try that one on your own. Please, please, please have that filled out before you submit this to me. Okay. Special cases. We're going to go over this first one here. And we're not going to fill out all the tables for it. But I just want you guys to notice something. Okay. Our special case here, this is just going to be no h term. Okay. What does that mean? Well, what that means is this is really, we could rewrite this as y equals 1/2 x minus 0. Because remember, if there's just nothing there, we can imply a plus or a minus 0. It would end up looking the same way after being simplified. So this is really what it would look like expanded out, which just means that our vertex would be 0, -3, and our axis of symmetry would just go through the line of 0. Okay? Let's go ahead and graph that one. our axis of symmetry is going to be down at x equals 0. Actually, I'm not going to write that out yet until we have the vertex put in, which is going to be 0, comma, -3, which is right there. And then the axis of symmetry is going to be the dotted line going right through it. Okay, now this one, if you notice, has a vertical stretch of 1/2. We're not necessarily going to know what that looks like off the top of our head, so this is where we need to actually try to find two different values. Okay, so if we have 0, comma, -3 as one of them, let's try it when x is 1. If I put 1 into that equation, my y output, I'm going to do this over on the side. If I have x in there, right there, as 1, 1/2 of 1 squared is 1/2, minus 3 is going to be -2.5. So this is going to be one where you're going to want to try and do your best just to see what it would look like, or where it would be on the graph, I should say, that point. So filling that out at 1 and -2.5 is going to be about right there. And then we're going to try it with the -1. Let's go to the other side. So -1 squared is going to be a +1, half of that, or 1/2 times that is just going to be 1/2. So again, we're going to have 0.5, or 1/2 minus 3 is going to be -2.5, -2.5. So we're just going to the other side and putting it in the same spot. Notice that these are going to be these dots are closer together, and they're not as vertically stretched. Remember, we know that because the vertical stretch is less than 1. So it's going to be a little bit wider of a parabola coming through this one. I missed that dot, but it's going through there. We're gonna act like it is. Okay. So that's just what it looks like with a special case of no h term. That just means it's a 0. And if we go to our special case number 2, you guys will be able to see that this is the same case if there's no k value. Now we've got an h value, no k. If I were to take this same equation, just put a +0 here, has no change on the equation, but it does tell us the y value of our vertex, and it does give us that k term. So in this case, our axis of symmetry is going to be a +3. Let me rewrite this. X equals a +3. Remember, it's going to be positive because it's the opposite of our h value. So the vertex is a +3 and a 0. So let's mark that down. 3, 0 here. Let's get those two other dots in there. If I have, let's go to the right, so a 4 minus 3, that's 1. So if I put x as 4, 4 minus 3 is 1, 1 squared is 1, half of 1 is a half, so this is going to be 4 at a half here. And then if we go to the other side, we're going to have 2 minus 3, which is a -1. Excuse me. -1 squared is also a +1. 1/2 times a +1 is a half, so it's also going to be a half here. Let's go ahead and make that stretched out parabola. And we'll put our axis of symmetry going through that vertex. There's our line of x equals 3. And you guys have now been able to graph a couple examples of a quadratic function modeled in the vertex form. Okay, so I want you guys to work on this. And remember, your big takeaways are here is using your h and k values to find the vertex. Your vertex is going to be the opposite of h is your x value in the vertex. K is your y value. Those are going to be identified in your vertex form right here. Okay, A is vertical stretch. H is going to give you your x value in the vertex, K the y value. We can use those to find the important characteristics when it comes to graphing quadratic functions. Okay, remember to go back up to the top. I filled in that table of all the missing values I wanted you guys to try on your own. So go and please do that. Remember to try 2B on your own. And we will talk to you guys later on. Thanks.